So guys, in this video, we are going to discuss about performance metrics, which are specifically used in binary classification, multi-class classification. We're going to cover topics like confusion metrics, accuracy, precision, recall, and F beta score. Now guys, let's say I have created a model using logistic regression. So I'm just going to rub this. So here, let's say I'm using a logistic regression. And in this logistic regression, we are able to classify what is the main aim in logistic regression. This is basically a classification problem, and we try to split this by creating a linear line. Okay, and already we have discussed about the cost function and all. Now suppose if I probably get a new point over here, this basically means it belongs to this category. Or suppose if I get a new point over here, it basically means it belongs to this particular category because it is below the line. Okay, now if I really want to understand how my model is actually performing, see, in linear regression, we discussed about something called as R squared, right? R squared and adjusted R squared. Now, these were the performance metrics that were used in the case of regression problem statement, right? Now, in the case of classification, what all things we can actually use? So we use specifically called as confusion metrics, accuracy, precision, recall, and F beta score. And in this video, we'll understand how through this particular topics we can understand whether our model is performing well or not. Okay, now let's consider this simple data set I had. Okay, now in this particular data set I have all these data points x1, x2, and this is my output feature, this is my output feature, this is my input feature, right? And this is my predicted feature. Predicted feature basically means this is basically predicted by model. Okay, this y hat. Okay, so this basically shows that when my true output was 0, my model predicted it as 1. And similarly over here, when my true output was 1, my model predicted as 1. Here it was 0, 0, 1, 1, 1, 1, 0, 1, 1, 0. Okay, so this is a simple data set, and I probably trained my model and I'm getting this kind of predictions. Now the first thing that you really need to understand is something called as confusion metrics. Okay, whenever you get this kind of outputs, okay, basically once you find out a prediction, the first thing is that you create a confusion matrix. Now what is a confusion matrix? Confusion matrix in the case of binary classification is a 2 cross 2 matrix. Okay, so I'm just going to draw this 2 cross 2 matrix. On the top, I'm basically going to draw, I'm just going to write 1 0. 1 0 basically means this is with respect to the output, ones and zeros are my output. Similarly on the left hand side, we are going to write 1 0. Now you really need to understand what the top 1 0 basically indicate. This indicates my actual values. Okay, everything will make sense, guys. Just focus on this actual values. And what this 1 0 indicates, it indicates something called as predicted values. Okay, now let's try to, now suppose if I have this real output and the predicted output, how can I fill the confusion matrix with this data? Okay, now let's say my real output was 0, but my model predicted it as 1. So over here, how do I map it over here? So my real output is 0. My model predicted it as 1, because I told you that this is the predicted part, right? So if it is 0 and my model is predicted 1, that basically means I've got this particular scenario. So I'm going to increase the count by 1. So here, let me write it down as 1. Okay, so I've got this particular count and this belongs to this particular box. Okay, similarly in the next field, you can see when my model, when my real output is 1, my model predicted it as 1. So this is fine, right? This is incorrect, this is fine, right? Our prediction should also happen like this. So where does this 1 1 actually fall? So 1 1 will actually fall over here, right? So we have something over here and I'm basically writing it. Okay, perfect. Then I have 0 0. So I have 0 0, it will be coming over here. So I'm going to increase the count by 1 over here. Then I have 1 1. Again 1 1 is there. So what I'm actually going to do, I'm going to rub this and I'm going to make this as 2. I'm going to increase the count. Then again I have 1 1, then I'm going to increase the count by 1 more. Then 1 2 3, then again I have 0 1. 0 1 basically means this is 0 and this is 1. So I'm going to increase the count to 2. Okay, so let's say before it was 1, now I'm going to make it as 2. Perfect. And then I have 1 0. 1 0 is nothing but this specific field, so I'm going to write over here. Now over here, you know that if I consider 1 1 value, this basically means my model has predicted correctly, right? Because this scenario is that my model have done the prediction correctly, because my real output was 1 and my prediction was also 1. And in this particular scenario, when my actual value was 0, my model is predicting 0. So this is also correct, right? So out of this all results, this diagonal elements are the actual correct results, right? And this diagonal elements are actually the wrong results, because when it was 0, my model is predicting 1, and when it was 1, my model is predicting 0. So these are my wrong results. Now this confusion matrix, I'm again going to draw over here, and I'm going to give you some notations over here. Okay. So let me draw it over here, and let me provide you some notations. Now notation 1 is over here. I'm using 1 0 1 0. Whenever I have in the actual as 1 and predicted as 1, so we usually say this is the correct scenario, so I'll be writing it as true positive. When the actual value is 0 and probably my model has predicted 0, I'm going to basically write this as true negative. And when my actual output is 0, but my predicted is 1, that basically means this is false positive. Okay. And similarly, if my actual output is 1 and if my predicted is 0, I'm going to basically call it as false negative. Now this is super important in respect to deriving all this formula of accuracy, precision, recall and F beta score. Okay, how we're going to discuss about it. Now out of this, if I talk about true positive and true negative, these are my correct results, and remaining F false positive and false negative, these are my wrong results. So if I really want to calculate my accuracy, so this formula will be true positive plus true negative divided by true positive plus false positive plus false negative plus true negative, right? So this is the specific formula with respect to this. Now what is true positive? Over here from this we can actually see this particular field. We'll just try to populate it. So it is nothing but 3 plus 1, because 1 is over here, 3 is over here, and then I'm going to add with 3 plus what is false positive. Obviously it is 2, then false negative is 1, and this is 1. So finally I'll be able to see that I'm getting 4 by 7. So this whatever value I'm getting is basically my accuracy for this particular model output with respect to this, right? With respect to this particular confusion matrix. So guys, now we have understood about accuracy. Okay. Now let's go ahead and understand about the next performance metric, which is called as precision and recall. And we'll try to understand when should we use precision and when should we use recall. Now let's consider that I have a data set. Okay. So I'm just going to consider, let's say I have a data set. Now in this particular data set, let's say that I have 1000 data points. Okay. So my entire training data set has basically 1000 data points. That basically means 1000 rows. And from this, I have 900 output categories as 1. So let's say this is a binary classification. Okay. Now one important thing that I really want to talk about is that suppose if we have a multi-classification, then the confusion matrix will not become 2 cross 2. Let's say if I have the number of output categories is 3, then this will basically become 3 cross 3 matrix. If the number of output categories are 4, then this becomes a 4 cross 4 confusion matrix. Okay. So let's consider that in my binary classification, I have 900 as 1 and I have 100 as, let's say 100 number of categories are basically saying it as 0. Okay. So in this particular scenario, you can see the ratio of the output categories with respect to ones and zeros are 9:1, right? So this basically becomes an imbalanced data set, right? Now in the case of imbalanced data set, I cannot directly use accuracy. See, I cannot directly use accuracy. If I directly try to use accuracy, let's say if I just create a blunt model, which is just saying that for all the input data point, I'm going to get 1. Then if you try to calculate, right, we'll be getting 90% accuracy. But in the real, it is not true, right? In an imbalanced data set, it can give you a completely biased result. So in order to fix this, we will try to use something called as precision and recall. Now we'll try to understand what exactly is precision recall and what is the exact formula with respect to precision recall. Okay. So first of all, let's go ahead and let's talk about the formula with respect to precision. Okay. So first topic that I'm going to cover over here is precision. Now I hope you have understood when we should not use accuracy. Let's say if you have an imbalanced data set at that point of time, I cannot use it because I'm getting this high accuracy for that, even though my model is bluntly saying 1 to every data points as an output. So precision is basically given by the formula true positive divided by true positive plus false positive. Now over here, the most priority is basically given on the false positive. Now let me make you understand what this formula basically says. So I'm just going to draw the confusion matrix again. Okay. And let's say this is my ones and zeros of the actual point and this is ones and zeros of the predicted point. So this is my true positive, This is my false positive, this is my false negative, this is my true negative. Now, this precision basically says that out of all the, see, when I say with respect to true positive and false positive, right? So we are basically focusing on this two, right? So what does this particular formula say, right? And we know that this is basically predicted and this is my actual result, right? So with respect to this, I can definitely say one very important statement, okay, from this particular formula. Out of all the predicted result, how many of them are correctly predicted? Okay, this formula basically says this, right? Again, let me write it down. Out of all the predicted results, because if we are referring to this, right, or if I am just referring to this, right, I can definitely say, okay, let me just make a little bit change over here again. Okay, let me make a simple change, because again I miss there is always a confusion with respect to precision recall. So let me just make this statement again. Okay, out of all the actual values, okay, because when I am referring to this two, right, so in short I am referring to both the actual values, ones and zeros. Okay, out of all the actual values, how many are correctly predicted? That is what we are basically going to find out with the help of precisions. Okay, so out of all the actual values, how many are correctly predicted? That is what this precision basically talks about. Okay, so again I'm going to repeat it. Out of all the correct results or actual values, okay, out of all the actual values or true values, we are going to find out that how many of them are correctly predicted. So that is the reason why we are dividing true positive by true positive plus false positive. Okay, so this is the example, and again I'll be talking about more examples as we go ahead. When should we use precision and when should we use recall? Now the second thing, if I talk about the recall formula, okay, my recall formula is something like true positive divided by true positive plus false negative. So now in the case of recall, I am considering this specific part, that is true positive and false negative. Now you can basically guess, and I can basically write out of all the predicted values, how many are correctly predicted, right? Correctly predicted. This is what we are trying to find out with the help of recall. And always remember, with respect to precision and recall, we should try to reduce this false positive and we should try to reduce the false negative. Now you may be thinking, okay, Krish, this is the formula, fine, but tell me, when should we use precision and when should we use recall? Okay, now let me give you some of the use case. Okay, let's say my first use case is I want to create a model which will basically do spam classification. Okay, spam classification. Now in spam classification, let's say my model, if my truth value is, right, if I get a mail and this is spam, right, this is spam, and if my model predicts this is a spam, then this is quite amazing, right? So this is the true positive result. So in short, my model is absolutely working fine. So this is good, right? This is how my model should perform. But let's say if my mail is not spam, and if my model predicts it's at spam, then what will happen? This is a huge blunder. Okay, blunder, because even though my mail was not a spam, my model is predicting it to the spam and it is sending to the spam folder. So by that way, I may miss my most precious email, right? So in this particular case, whether we should reduce false positive or false negative, now you need to understand over here, obviously. And obviously this all knowledge comes from domain expert also, but you should start thinking whether I should use precision or recall or something else. Okay, so let's say this is 1 0, this is 1 0. Now in this particular case, if I say 1 basically means spam, 0 basically means not spam, right? So let's say this is spam and this is not spam. This is the predicted output. Now in this particular scenario, when my mail actual value is here, right? When my mail is not spam basically means here, and it is model is predicting as spam. So this is the error it is basically calling, right? It is basically coming up with false positive error, right? This is obviously true negative, this is false negative. But in this particular case, this is a blunder, right? So in this use case, I should try to reduce false positive, because we understand that this kind of situation is a major blunder. Okay, major blunder, because when the mail is not a spam, my model is predicting it as a spam. So when my mail is not a spam, 0, my model is predicting as 1. So this is basically false positive. So we should try to reduce false positive over here, and for this particular case here I will be using precision, because precision formula is nothing but true positive divided by true positive plus false positive, right? So this is the formula of precision. Now you may be thinking, okay, this is my use case 1. You may be thinking, Krish, then where can you tell us some use case which actually deals with false negative? Okay, let's go with the use case 2. Okay, use case 2. Let's say over here, my problem statement is to detect or to predict whether person has cancer. I'll not say cancer, that is a very big disease. So whether the person has diabetes or not. Okay, let's consider this particular problem statement. Now in this scenario, let's say if in truth, right, let's say if I probably take as an example, let's say in the truth, the person has a diabetes. Okay, and my model predicts the person does not have a diabetes. And my model predicts the person doesn't have a diabetes. Then this is also a very big blunder, right? This is also a very big blunder, because if the person is having diabetes, my model should be able to predict that the person should have diabetes. Let's say in truth, if the person is having diabetes and my model predicts it has diabetes, then this is good, right? My model is performing absolutely fine. Similarly, if I say in truth, let's say my model is not having diabetes, in truth, the person is not suffering from diabetes, but my model predicts that the person is having diabetes. So this is also wrongly predicted. But can I say this is a blunder scenario, right? Even though the person is not having diabetes, but the model predicts as diabetes, but it's okay, right? The person will go and probably again recheck or take second opinion in the hospital, right? So this kind of error is fine. It can happen. Not a worries with that, but we need to not focus much on this, because the person can go with respect to second opinion and they can actually check. Okay, they can actually check in the hospital by doing various tests, right? So in this particular scenario, we will not focus on this, but this scenario will try to focus. Now in this scenario, should we focus more on false positive or false negative? Let's say I am just again creating my confusion matrix, and here I'll say person has diabetes and person has no diabetes. Okay, and this is with respect to the actual value, and here also person has diabetes and person has no diabetes. Now in this particular scenario, the truth is that the person has diabetes, okay, but the model is predicting the person does not have diabetes. So what in this particular case, what is happening? We are getting false negative as a blunder, right? So this is the most important error in this use case, in the use case of medical, right? In the use case of diseases, and this gets applied to every disease, guys, right? So we should try to reduce false negative, because if the person has diabetes and if my model is saying it does not have diabetes, the person does not have diabetes, then the person may also not go even for checkup, and he may miss that, and because of that, the diabetes may be a dangerous disease going ahead, right? And if we try to treat it in the early stages, some type of fixtures, will be able to prevent it, right? In the initial days, if you are able to capture that, right? So in this particular case, I should try to reduce false negative. So in this case, I'll be using a recall formula, because in my recall, the formula is true positive divided by true positive plus false negative. So in this case, we will focus more on false positive to reduce it, right? So in this use case, our main focus should be that we should try to reduce false negative, right? So now I have told you with respect to different use cases, when you should use precision and when you should use recall. Okay, let me tell you one more simple problem statement. Okay, and then you try to do it as an assignment. Okay, and probably write down in the comment section. What if I really want to, like my model wants to predict tomorrow the stock market will crash or not? Stock market will crash or not? Crash or not? Now suppose if this is my use case, what do you think we should focus on? Reducing false positive or reducing false negative? Now this should be the answer coming from you. Just try to plot that again, confusion matrix, and try to understand and get it. Okay, so you can definitely try to do this and let me know the answer. This will be quite amazing if you are able to talk about it. Okay, now let's go with respect to the one more amazing performance metrics, which we basically say as F beta score. Now in F beta score, the formula that is basically given is 1 plus beta square precision multiplied by recall divided by precision plus recall. Okay, so this is the formula that we basically use for this. Okay, now let's say if, because what will be this beta value, we will be selecting it if false positive and false negative, because for some of the use case both false positive and false negative can also be important. If false positive and false negative are both important and we really need to reduce both of them, then my beta value is basically selected as 1. So here now, if I talk about this, this will basically become F1 score. F1 score is equal to 1 plus 1 square, and this will be precision multiplied by recall divided by precision plus recall. So in short, if I probably consider this value will become 2 multiplied by this one. And this term is basically called as harmonic mean. Okay, harmonic mean, because this is nothing but the harmonic mean. I think you have heard of geometric mean, harmonic mean, something like that. Okay, so this formula basically says about F1 score. Now, this is my first condition. My second condition is that, let's say if FP is more important, that is false positive is more important than false negative, then what we do in this particular scenario is that we try to reduce our beta value. So now we will be selecting our beta value is 0.5. So this F.5 score will be, in this particular scenario, what FP is more important than Fn. So here I will be getting 1 plus, the formula is beta square, which is nothing but 0.25. Okay, and this will be precision multiplied by recall divided by precision plus recall. So this is the formula with respect to this. The final condition is that if false negative is more important than false positive, at that point of time my beta value will become 2. So F2 score is nothing but 1 plus 4 precision multiplied by recall, precision plus recall. So this is my final output with respect to all the things. So if you consider if false positive is important, if false negative is important, if both are important, you can also use F beta score. Otherwise, you can also go with precision and recall. So I hope you have understood about all the performance metrics that we have discussed. This is just the part 1. In the part 2, we are going to discuss about ROC AUC curve. So yes, this was it. And in the next video, we'll be discussing about that specific thing. Thank you. I'll see you all in the next video.